1.1.6 Ephemeral versus Persistent Resources. Compute versus Storage Concepts. We're now at one of the most important distinctions in cloud architecture: the difference between ephemeral resources and persistent resources. This single distinction affects durability, availability, reliability, scaling, observability, and even incident response. And once it clicks, many engineering decisions become obvious. This is also one of the moments in an interview where senior engineers separate themselves from people who just use tools. So let's get into it. Every cloud resource behaves in one of two ways. Either it is ephemeral, temporary, and disposable, or it is persistent, durable, and state-bearing. This isn't academic categorization. It exists because distributed systems behave radically differently depending on whether something keeps memory or not. Let's make it practical. Ephemeral resources are the compute environments that can appear, disappear, restart, scale, or fail. And the system should continue working correctly. Think of auto-scaling groups in AWS. When traffic spikes, AWS creates more virtual machines. When traffic drops, AWS removes them. Those nodes are temporary by design. Or containers in Kubernetes. Pods die, restart, reschedule, and relocate. If losing a pod breaks the system wasn't designed correctly. Or serverless compute, like AWS Lambda. It spins up, does the work, and vanishes. Or workers reading messages from Kafka or SQS. Workers crash and restart all the time. The system doesn't blink. Here's the mindset shift. Ephemeral means disposable compute. And from that comes the rule every cloud engineer must hold in their bones: never store state inside ephemeral compute. Because when ephemeral disappears, everything inside it disappears too. And the minute someone violates this rule, systems become fragile. There's a famous failure scenario where logs were stored locally inside ephemeral containers. When the container pool scaled down, all critical debugging traces vanished. The incident review was brutal, but the lesson was priceless. So the data must live somewhere else, somewhere persistent. Now, persistent resources. These are the systems that hold memory, the long-term truth of the application. Relational databases like Amazon RDS, Azure SQL Database, or Cloud SQL are persistent. Data survives node restarts, failovers, and upgrades. Object storage like Amazon S3 or Azure Blob Storage is persistent. Logs, media, ML datasets, backups, they stay. They don't vanish because a compute node vanished. Block volumes like EBS remain intact even when the compute instance is stopped, replaced, or redeployed. Kubernetes stateful sets rely on persistent volumes. The pod restarts, but the volume remains. Even event logs in Kafka are persistent. Messages stay, even while producers and consumers churn. This is the backbone. Compute is replaceable, memory is not. Or in one sentence, you can rebuild compute nodes. You cannot rebuild data. Let's connect this to architecture. In a load-balanced web service, the front-end nodes are ephemeral. They scale, restart, crash, get replaced. Nobody cares. That's correct behavior. But the database behind them is persistent. That's the memory of the system. Lose that, and you have amnesia. In a distributed worker system, the workers are ephemeral. They might restart 10 times a minute. But the message queue, SQS, Kafka, must not lose messages. Execution is ephemeral. Memory is persistent. That's modern cloud architecture. Why does the cloud force this separation? Because elasticity depends on disposability, and persistence depends on continuity. Those two goals cannot live in the same place. If compute cannot disappear, scaling is impossible. If data disappears with compute, correctness is impossible. So the cloud splits the responsibility. Ephemeral resources run execution. Persistent resources hold memory. This separation is not a convenience. It is what makes distributed systems reliable. Flexibility belongs to ephemeral compute. Reliability belongs to persistent storage. Now let's make this interview friendly. If someone asks,
What does ephemeral mean in cloud computing?
or
Why do we separate persistent resources from compute?
you answer, ephemeral resources are disposable compute units. They scale, restart, or terminate at any moment. Persistent resources retain data across those changes. The rule is, logic runs in ephemeral compute. State lives in persistent storage. That single line is enough for someone listening to immediately think, okay, this person understands architecture. Let's close this section clearly. Ephemeral is the execution engine. Persistent is the memory substrate. When those roles mix, systems become fragile. When they're separated, systems become resilient. And anytime you're uncertain in design discussions, just ask, is this about execution or is this about storage? That question clarifies most architecture problems. Now that we've seen what can disappear and what must remain, we can finally look at how systems stretch and shrink as demand changes. Up next, elasticity and scaling, horizontal versus vertical. End of section 1.1.6.